I'm Dr. A. Mahesh Babu, Professor, Department of Civil Engineering, NALLA NARASIMHA REDDY Education. So, group of institutions, integrated campus, Hyderabad. Structural engineering, one reinforcement concrete structure. In Unit 4, I explained how to design columns, short columns, long columns, as per IS codal provision. Here I am going to explain one more problem to find the column size and the area of compressive steel. Design a short rectangular tight column. He mentioned as a short column to carry a factored axle load of 3000 kilonewtons using M20 grade concrete and ME 415 steel. The column is effectively held in position at both ends and not restrained against rotation at both ends. Hinge the unsupported length of the column 3 meters. So what he has given in the problems, if you see, PU is given axial load factor load that is given 3000 kilonewtons. And what is the grade of concrete? M20, 20 kilonewton per 20 newton per mm square, and Fe is characteristic strength, and yield stress of steel is 415 newton per mm square, and the condition is effectively held in position at both and not restrained against rotation. That is, if you see this E annexure table number 24, here you see this, you can see this one restrained, effectual position and restrained against rotation at both ends. This condition, that is L equal to 0.65 L, you have to calculate here, both and hinged. Here both hand hinged means that is a not restrained, means that is a different again. You have to go for not restrained, this one. Okay, that is 1 L, L equal to 1 L, right? So here, and we are asked to find out the column size and area of compression steel. How to calculate? Now column size is B and D. E minimum is always less than 0.05 D as a short column or B. Okay, assume column and class 39.3. If you see column 39.3 here, if you 28 39.3, if you see here column here, if you see short axially loaded column, the member shall be designed as given assumption 30.1 minimum eccentricity. When minimum eccentricity as per 25.4 does not exceed 0.05 times lateral dimension, whatever it may be, shorter direction or long direction. Okay, the members may be designed for this equation, P equal to 0.4 FCK AC plus 0.67 FY ASC. Here where P is axial load on the member, FCK is characteristic strength of grade of concrete, AC is the total area of column section, 0.67 is multiplication factor, Fy is characteristic strength of compression steel, and ASC is longitudinal compressive steel. So as per this 39.1, this you have to implement here. Now we are given B equal to that one, and here we can assume this is a what is minimum ratio, 0.8% to 4%. So assume a area of compression steel that is 2% of AZ, total cross section area AZ. So your area of compression steel is 0.02 BD. Here assumption is important because they say limit state method, that this is the optimistic method. So we have to calculate area of compression steel 0.02 BD. Now area of concrete equal to BD minus ASC, that is BD minus 0.02, that is equal to 0.98 BD. Okay, and BO equal to 3000 into 10 power 3, that is equal to 0.4 into 20 into 0.98 BD. So plus 0.67415 into 0.04 BD. This is AC. This is applicable to this equation, nothing but here this equation is applied, this one. If you see this equation, Here we use this PU equal to apply this equation. So from this equation we calculating the data unknown givens. That is A is equal to here B minus D and minus area of steel. That is here. If you substitute from the above data, you will get 0.98 BD. Now 3000 into 10 to the power t equal to 0.4 into 20 into 0.98 BD plus 0.67 into 415 into multiplied by 0.0 BD. Now what is BD? You will get this is 2,23,864 mm square. Assuming D is 1.5 B. Now depth and breadth ratio assume 1:5. Then you will get 386 and 579. So about column size is 400 by 600, around 24, 2,24,000 column. So it's more than what required. In this way, we have to calculate B and D. Now, area of concrete is equal to this area of total concrete minus area of steel. Now, how to calculate this total column section is this 400 into 620, 2,40,000 minus AAC. And PU, you know, substitute in the given equation, you will get area of steel, that is 0.4 FCK, AC is 24,000 minus AC, because you will get area of concrete only. And here 0.6745 is area of compression steel. So here area of calculated is 4,000 mm square. So how to calculate? Here again we use this formula. From this formula only, here we calculated this area of compressive reinforcement. Okay, and now rebar details, that is ties. Provide 6 mm. What is the total reinforcement required here? 4,000 mm square. So provide 625 bars and 420 mm. For 6 bar, each 25 bar is around 415 into 6, and that is approximately equal to 490 into 6. So approximately 295 mm square, and 420 mm square, that is 315 mm square into 4, that is 1257 mm square. Total you will get 4,202 mm square, which is more than 4,000 mm square. So in this way, you have to calculate. What we did here, first assumption, ice per column, it should be less than minimum 0.05 D. Now PU you know, and from that we calculated and assumed that P equal to 1 by 1.5 D. Generally, this is the size provided in the general size. So that's in that way we calculated P and D. Then we calculate area of steel 4,000 mm square. Now we will cross check and will provide for 625 mm and 420 mm. So lateral ties, how to provide lateral ties? Here diameter not less than the larger of 4, that is D by 4, that is 20 by 5, 4, 6.25 mm or 6 mm. That's why from both you can adapt 8 mm. So pitch may be the, and you should not be less than, that is width of column, that is 400, 16 times of least dimension bar, 16 into 23, 20 mm or 300 mm. So provide least dimension 300 mm. So rebar bars, tie bars, we calculated lateral ties adapt to 8 mm bars at 300 mm center to center. This way you have to calculate. Here if you see now 325 mm one side and 220 mm sides. Again this is a stirrups, and these are 8 mm stirrups. Okay. Here if you see here 400 mm thickness, this is width, and 600 width. Clear cover you have to provide 400 mm. As here is one ring, and this is a 2 stirrup. In between 420 mm and 6 25 mm bars provided in this figure. Spacing of longitudinal bars in both direction less than 300 mm. It's okay according to IS 456. Now, if you see, check for standardness from K equal to 1, I explained. If you go for E and see this table and this condition, you check first condition, effectively held position and restrained against rotation, both and this not. No, so this is the given problem is effectively held in position at both end but not restrained against rotation. That is both sides hinged, that is L equal to 1 L, that K equal to 1 here you have taken. Now LEX, LEU equal to KL, that is 3000 meter. So LEX by D, that is lateral dimension 5, it is less than 12. So slenderness we are checking. So it is not long column. And LEU by LX, that is 3000 by 4, it will be 7.5. So it is also less than 12. Hence it is a long column. In this way we have to mention, and we have to check for minimum eccentricity. That is L by 500 plus T by 30 equal to 26. Now, what is minimum eccentricity? 0.5D, that is 500 is equal to 30. 30 is greater than 26. Then it's okay. Now, in shorter direction, 3000 by 500 plus 400 plus 30, it is 19.33 and it is less than 20 mm. Then it is okay. So both directions, it is approximately 20. So 0.05 V is 20 mm. Then it's okay. So this is class 39.3 of IS 456 applicable in this problem. So in this way, you have to check the problem. In this session, thank you all.